Welcome to BSc Statistics students. In this class, I explain one of the important topic in game theory, games without saddle point, that is mixed by using mixed strategies, which means if the saddle point does not exist for any game, then how to calculate the value of the game and optimal strategies uh, which are going to be calculated, that is considered calculated, uh, and how this particular theory is going to be explained, that is by using mixed strategies, that is by using certain probabilities and a mixture of strategies, mixture of pure strategies with the help of some certain probabilities, certain chances, probabilities. That is what the discussion of games without saddle point, mixed strategies, right? Now, is it clear? For which that I consider, that is the payoff matrix of player A. So there is a usual consideration for any particular game. The payoff matrix is compulsory, right? So it is represented in terms of payoff matrix. For example, I consider player A and player B. There are two particular players are playing a game, and with the payoff matrix of player A, which are going to be represented. For example, player A having M strategies, A1, A2, and so on, AM, and player B is having N strategies. Let it be B1, B2, and so on. Let it be Bj, J is equal to 1, 2, and so on, N, I is equal to 1, 2, and so on, M, right? A1 to AM and B1 to Bn. So I'm considering in this way, and so that this is the matrix, payoff matrix, where the elements of payoff matrix, that is whose payoffs are going to be considered by A11, for example A1 for all B1, B2, Bn, A11, A12, and so on, A1j, and so on, A1n, right? And similarly A21 for A2 and all B's, and A22 and so on, A2j, and so on, A2n, and so on. Coming to the general one, ith1, AI1, AI2, and so on, AIJ, and so on, AIN, and similarly, and so on, AM1, AM2, and so on, AMJ, and so on, AMN. So this is the payoff matrix I have considered for player A, and certain values which are represented for player B, that is player B. If this is gain for player A, this is loss of the player A, this is loss of the player B. Hope this is we have discussed in the definitions of payoff matrix, etc. Now the question is how to consider the maximum value and minimax value. So certainly I explained the maximum and minimax values, minimax principles or values for player A and player B in this particular class. The games without saddle point by using mixed strategies, and what would be the maximum value and what for player A, and what would be the minimax value for player B in this particular session, right? Right, if you consider, for which you have to consider certain probabilities. For example, P's, that is Pi, which are probabilities for player A to select a certain strategy, which means that I consider P1 is the probability. I'm writing here, that is for very, very important purpose. I'm writing here probability P1. For example, P1 is probability of selecting the strategy A1 of player A. Similarly, P2, and so on, Pi, and so on, Pi, and so on, Pm, which are the probabilities of selecting the strategies of player A. For example, Pi, general one, probability of this is Pi is probability of selecting the strategy AI, ith strategy of player A. To select this particular strategy, this is probability. Similarly, you consider probabilities of selecting the player B. One of the strategy of player B is Q. So for which you can consider, you write here, that is just above the B, the strategy that is B, so that it is so convenient. I'll tell you. the probability of selecting the second strategy B2, I'm considering Q2 and so on. I'm considering QJ is the probability of selecting jth strategy, general one of BJ of player B, and so on, which are Qn is the probability, right? So where Pi is greater than or equal to 0 and Qj is greater than or equal to 0. This is for all I and for all j. Pi is greater than or equal to 0 for all I. Qj is greater than or equal to for all j. That is for I is equal to 1 to and so on m and j is equal to 1 to and so on n. All probabilities must be greater than or equal to 0. And also P1 plus P2 plus and so on plus Pm. If you consider all probabilities, you should get 1. Similarly, Q1 plus Q2 plus and so on plus Qn, which must be equivalent to 1. So these are the minimum properties, minimum requirements of considering the probabilities. Minimum certain rules and probabilities and certain rules and some properties are going to be satisfied to the probabilities. So the combination of now these probabilities with the pure strategies, pure moves, that is A1, A2, AM, etc., B1, B2, Bn, which gives you the value of the game, etc. Right. So therefore, now the study is required. The study is required on maximin principle and minimax principle. For example, now I consider maximin value, maximin principle of player A. This is for player A. Player A. How to consider this? How to calculate maximin principle of player A? For which what I am considering two important particular things. So one, B's pure move, that is B's pure strategy, and A's expected gain. It is also known as payoff, or A's expected payoff. You can consider gain means payoff. It is obtained from the payoff matrix. Usually what we do for maximum principle, it is required to calculate maximum among minimum gains. That is for player A. Usually in the saddle point, if the game exists, game have a saddle point. A game has a saddle point. If it is if that it does not exist a saddle point, then we have to consider the mixed strategies. Clear? If a particular game not having the saddle point does not exist, then in such a case you have to consider the mixed strategies, that is probabilities. In such a case, what we have to consider, if player B uses one particular strategy, then what would be the gain for player A, which always will be given to the minimum gain. Among minimum gains, the player A has to select the maximum, that is called maximin value, which are called expected gains. Now I'll show in the table, that's very important. So for example, player B uses strategy B1, then what would be the expected gain for player A? That is, we have to think out. We have to think in that direction. If player B uses this particular strategy B1, then what would be the expected gain for player A? That is, we have to think out, right? So it is very easy. That is the reason why I have written these values here. You see here, these are the payoffs. If player B uses this particular strategy, these are the payoffs of player A. First column, A11, A21, AI1, AM1. Then by using this, with the combination of probabilities, if player A uses P1, replies with P1, then payoff is A11 into P1. Expected payoff is A11 into P1. It's very simple probability concept, expectation concepts. A21 into P2 plus and so on, plus AI1 into PI plus and so on, AM1 into PM. So that is what if player B selects the strategy B1, then this is the reply, and player A will expect this much gain I will get if player B uses this particular strategy. That is going to be observed just by simply multiply first column with probabilities P. You will get it. Similarly, player B uses the strategy B2, then you multiply this column with probabilities, that is payoffs of player A with probabilities. Then you will get expected gain, minimum expected gain for player A. Similarly, if player B uses Bj, you multiply this column with P's and probabilities. If player B uses Bn, then multiply this column with P. You will get expected gain. These are all expected gains for player A. If player B uses one such strategy, that is what that is required to calculate now. So I write here B's pure strategy. I am writing here B's pure strategy. For example, I am considering B1. Then just now I explained that you have to multiply, again I show, you have to multiply with A11 with P1 plus A21 into P2 and so on, AI1 into PI, AM1 into PM. So I am writing here the expected gain for player A, I am considering as G1 or E1P, expected value in terms of probability from the first strategy like of B1, right? So it is equivalent to be A11 P1 plus A21 P2 plus and so on, plus I am writing last one AM1 PM. Similarly, for example, player B pure strategy is B2, that is player B plays with the start the game with the strategy B2, then expected gain for player A is represented by G2 or E2P from the second strategy, that of player B, right? The expected gain is, I'll show you in the matrix, A12 into P1 plus A22 into P2 and so on, AM2 into PM, right? Clear? So I'm writing here, it is nothing but A12 into P1 plus A22 into P2 plus and so on plus AM2 into PM. Similarly, and so on, I am writing the last one, Bn, if the strategy Bn. If player B uses the strategy Bn, then the expected gain, minimum expected gain of player A is A1n into P1 plus A2n into P2 and so on, AMN into PM. Now, have you understood why I have written the probabilities here? If you write the probabilities here, you can easily understand this one. You can easily calculate this. You have to write the probabilities just at the values of A1, A2, AM. You have to write the probabilities of player A, right? So therefore, now expected gain for player A, the minimum expected gain, if player B uses the strategy Bn, then Gn, you consider Gn, EnP is equivalent to be A1n P1 plus A2n P2 plus and so on plus AMN PM. So this is what that is consideration of the expected gains. Expected gains. If player B uses the pure strategy, then what would be the expected gains of player A? This table represents this, right? Now these are the, you please listen clearly, these are the minimum expected gains. Now what we have to do is, player A required to do, that is player A always looking to maximize his minimum expected gains. If player B uses this one pure B1, then this is the expected gain for minimum expected gain for player A. If player B uses B2, then this is minimum expected gain for player A. Similarly, if player B uses Bn, this is minimum expected gain for player A. Among these minimum expected gains, the player A would like to always maximize his minimum expected gains. That's all. So that is the formula is going to be applied. I write in simple way so that you can easily understand. That is the maxi-min value. It is represented by mu underscore is equal to maxi-min. First of all, I am writing it is equal to maxi-min. So this is going to be calculated by maximum of in terms of mixed strategies, by using mixed strategies. The maximum of, that is the probability is going to be find out. The which probability gives the that is a particular strategy which uses that which highlight and which going to be put in a leading position to that particular player, that is player A. So which particular probability do that? That is, it leads to always going to be put in a comfortable and comfortable position, right? That is what we are calculating. Maximum of P, the minimum of expected gains. Expected gains, so that you can easily understand. So minimum of expected gains. What are the expected gains? These are the expected gains. 1, 2, 3, and so on, n. Right? So therefore, it is going to be calculated by maximum of the probability, one such p value, either p1 or p2 or and so on pm, which gives you a leading position of that particular of that particular game by for the player A. That is called, that p gives you, or that b gives you a maximum value, right? That is what I want to explain to you, right? So this is nothing but that I am calculating minimum of here, the minimum with respect to j, it is going to be considered because j is equal to 1 to and so on n. You see here, among these gains g1, g2 and so on gn, and simply I am writing g1, g2 and so on gj and so on gn, right? Is equivalent to be maximum of p and minimum of j. Now I write the formula in this particular step. The first one, g1 is nothing but a11 p1 plus a21 p2 plus and so on plus am1 pm. That is the first one. The second one, similarly, if you consider the second one, a12 p1 plus a22 p2 plus and so on plus am2 pm and comma and so on and so on. For all, you have to consider nth one, comma a1n p1 plus a2n p2 plus and so on plus amn pm. So this is what you have to calculate, and this value is nothing but mu underscore. It is represented with mu underscore, and which gives you maximum value for player A. Now, similarly, you have to obtain, this is what maximum principle for player A. And now you have to discuss about minimax principle, right? So I'll write in another page, right? Now I write here that the minimax principle. What is minimax principle? Principle for player B. For player B. Okay. So for this, I prepare the table here. A's expected gain, that is A's pure strategy. I'm sorry, A's pure strategy. And with this, I consider B's expected loss, which is also known as payoff. Expected loss is also going to be considered as payoff, right? How to consider this? I explain again. For example, if player A plays with game with one particular strategy, for example, you see here, this is the matrix we have considered, the payoff matrix. I'm sorry. If player A uses strategy A1, then what would be the expected loss for player B? That is going to be calculated by taking all these particular payoffs of player B, A11, 12, A12, A1J, A1N, with the probabilities. That is, expected value is going to be calculated by taking x multiplied by p of x, summation x multiplied by p of x. So same formula, A11 into Q1, A12 into Q2, and so on, A1J into QJ, and so on, A1N into Qn. If you add all these, you will get the probability, that is expected value. So the expected loss of player B is going to be calculated by using this kind of formula. And similarly, for example, player A select the strategy A2, then the expected loss for player B is A21 you have to multiply this particular row with Q1, Q2, Q1. A21 Q1 plus A22 Q2 plus and so on plus A2n Qn, like that. Similarly, if player A uses the strategy AM, then expected loss for player B, AM1 into Q1 plus AM2 into Q2 and so on plus AMN into Q1. This last row, it is going to be multiplied with Q1, Q2, Q1. You will get it. That's all. Among these maximum expected losses, why? Because player A always looking to give one of the maximum losses. So these are the maximum losses. Among these maximum losses, player B would like to minimize his maximum expected losses. So this is called mini-max, right? So now I write here in a particular form here. If A's pure strategy is, for example, A1, then B's expected loss, it is going to be considered as L1. It is also represented by E1Q is equivalent to B. Just now I have explained from the matrix A11 Q1 plus A12 Q2 plus and so on plus A1n Qn. Okay, right? Similarly, now you consider if player A uses strategy A2, plays with the strategy A2, then the expected loss for player B is, let it be L2, it is E2Q is equivalent to B, it is A21 Q1 plus A22 Q2 plus and so on plus A2n Qn. Similarly, for example, player A uses the strategy AM, then B's expected loss is LM, it is equivalent to B, EMQ is equivalent to B. Let you consider it is AM1 Q1 plus AM2 Q2 plus and so on plus AMN Qn. So this is what the table which represents what are the maximum expected losses for player B. Clear? Is it clear? So this is what the next discussion. This is a very big discussion in the game theory, right? So which means now how to calculate the minimax value? Minimax value, which means the minimax value in the is represented by mu underscore is equal to minimax is equal to minimum of, you have to calculate one such probability which put the player be in leading position, in a good position. So that strategy is going to be considered with the probability Q. The probability Q gives you and it represent you and it allocate and such a particular strategy, use of the one particular strategy, it is it gives you in a very good position. It indicates that it gives you in better position. That is what you have to consider. That is the reason why we have to calculate which minimizes, which Q minimizes this particular maximum expected losses, and that is a strong strategy of player B. Right? Hope you understand. Right? The minimum of maximum expected losses. Expected losses. So which means here we have to consider minimum of maximum expected losses here, for which you have to consider maximum of for example, in terms of I we have to calculate, because I is equal to 1 to m here. I is equal to 1 to m here. M expected losses here. Maximum expected losses here. So among from which you have to consider L1, L2 and so on LM. Right? And which is the discussion now. You have to consider minimum of Q and which maximum expected losses, which means you have to consider maximum amongst these values. You have to consider one I is equal to one such value which gives the minimum value. At all i's, that is at all L1, L2 and so on LM, you did not get the value of m is that is one particular value is minimum at all values. No, one particular value will give the minimum. So we are considering maximum of I. So that is I'm writing A11 Q1 plus A12 Q2 plus and so on plus A1n Qn. And so, and similarly, if you consider A21 Q1 plus A22 Q2 plus and so on plus A2n Qn, comma, and so on, which means L1, L2, Lm I am writing. A comma A M1 Q1 plus A M2 Q2 plus and so on plus A Mn Qn. This is what minimum of maximum expected. These are the maximum expected losses, among which one particular value which gives the minimum expected loss. That is called mini-max value. Mu upper score. Mu upper score, minimax value is going to be identified with the help of the mixed strategies, which means in terms of probabilities, by using some combination of probabilities, which probability which gives the minimax value among q that you have to consider, and similarly maximum value, which value gives the maximum one such probability, p provides that. So like this this is a kind of discussion of considering the entire game theory for remaining all the procedures and many principles are based on this particular fundamental important concept for mixed strategies, games without saddle point. Thank you so much.